Hey guys, Roland here coming at you live from Coronatine. Let's see. Could not have been a more timely lesson in history here. We've got a whole lesson on exponential functions, and we're studying a virus that spreads exponentially. So let's get at it. Okay, so we've talked in the past about parent functions. The parent function for a standard linear equation is just y equals x. For quadratics, it's y equals x squared. For cubics, it's y equals x to the third. And then we even talked about the absolute value function. Here's the parent function for exponentials, y equals 2 to the x. So when we talk transformations, when we talk shifts, dilations, stretches, compressions, reflections, all that can be thought of as a manipulation of this parent function, y equals 2 to the x. So let's have a look at it. So y equals 2 to the x, if I were to raise 2 to the negative third power, we've learned that all that does is raise 2 to the third power, but then turn it into division essentially, and move that 2 to the third power to the denominator, and we get 1/8. 2 to the negative second will be 1/4. 2 to the negative first would be 1/2. 2 to the 0, well, anything to the 0 power is 1. And then here's your easy ones. And so if we were to plot that, I begin with the positives and 0. I begin by plotting this point, the y-intercept. And then 2 to the first is 2. But 2 to the second is 4, so it comes to 2. And then 2 to the third is 8. And then I gotta eyeball the low end here. 2 to the negative 1 is 1/2. And then you just kind of cut that in half and cut that in half. And at that point, we're kind of limited with our hand drawing and our graph, but we have this term that we've talked about before, an asymptote down here. And that is this curve is going to get closer and closer to the x-axis there without ever actually touching. So let's go ahead and label that. And that's it. That's y equals 2 to the x. So that's exponential growth, and that's why this virus is so dangerous. I mean, the spread just takes off like a rocket. Now we're going to look at a manipulation of that function, which is y equals 1/2 to the x. So let's start with the positives again, and 0. 1/2 to the 0. Anything to the 0 power is still 1, even though it's a fraction. 1/2 to the 1 is 1/2. 1/2 to the second is 1/4, and 1/2 to the third is 1/8. And the beauty part is that the negative exponents are just going to flip that 1/2 back into 2 over 1, which is 2. So we're really just going to have the reciprocals of these positive exponents. And then we're going to see that this is just basically going to turn into a reflection of the original y equals 2 to the x in the y-axis. Again, I start with 0 and the positives usually, so now I'm going to start with 0 and the negatives. Work my way that way. 1, 2, 3, 4. And down here are our fractional components. And so now our graph takes off like a rocket on the left side, and the asymptote is on the right. Okay, moving on. Example 24 says, based on the graphs and the behavior you saw in example 22 and 23, state the domain and range for an exponential function in the form y equals b to the x. So the domain is all real numbers. In set builder notation, we write that like this. And in interval notation, from negative infinity to positive. The range, though, in set builder is y is greater than 0, and in interval from 0 to infinity. Now there is no value at 0, so parentheses on both. Are exponential functions 1 to 1? The answer is yes. Simple as that on a graph. Apply the horizontal line test. Remember, the vertical line test tests whether it's a function in the first place, and then horizontal line test is 1 to 1. What does this tell you about their inverses? This means that their inverses are at least functions, which means they'll pass the vertical line test. That's a little review from a previous unit. Are exponential functions even, odd, or neither? Well, remember, to be even, you have to be a reflection of yourself in the y-axis, and that's not the case, so no, they're not even. To be odd, they have to be symmetric when rotated 180 or reflected in the origin, and that's not the case either. So they're neither. All right, 27. We got a function 7 times 3 to the x power. Note the order of operations here, gang, that we're dealing with an exponential function 3 to the x power, then getting multiplied by 7. So the exponent happens first. Okay. All right, y-intercept. Remember, y-intercepts are where x equals 0. So I'm just going to plug in 0. Again, exponent part happens first, so we got 7 times 1. Anything to the 0 power is 1, but that doesn't mean the entire expression is worth 1. 3 to the 0 power is worth 1. We have 7 times that, so we have 7, so the y-intercept is 7, which means we're going to have a point at 0, 7. Does the exponential function increase or decrease? Well, just like you saw on the previous page, remember y equals 2 to the x, took off like a rocket like this, and y equals 1/2 to the x like this. Ours is much more like this guy in that this base of our exponential expression, the 3, is larger than 1. Sorry, anything larger than 1. Let's see, since our base is greater than 1, it's going to increase to the right. It increases as we read from left to right. Does y equals 7 times 3 to the x have an x-intercept? Explain algebraically. Okay, so y equals 0 when you cross the x-axis. So we could plug in 0 and solve this equation. Here's the problem. It's not a problem right out of the gate. I can divide both sides by 7. 0 divided by 7 is 0. So now we have 3 to the x equals 0. And you got to find a value that you could put in there that would make 3 to the x power 0. The problem with that is you saw with even like your negative exponents, the negative exponents are going to get closer and closer to 0. but they're never actually going to touch. We're just going to get a smaller fraction every time. Sorry, I'm jumping ahead to 3 to the negative third, but no matter what, this fraction is just going to get smaller, but it's never going to equal 0, and we see that with the asymptote. So no. We have an asymptote along the x-axis. Y equals 0 is, yep, referred to as a horizontal asymptote of f of x. Y equals 0 is a horizontal line. The graph is approaching. We're going to create a rough sketch. Okay, so to create a sketch here, I'm going to begin with the fact that the y-intercept is 0, 7 that I found up above. And since it's a sketch, I'm just going to mark it, roughly here. And what else do we want to show? That it's increasing to the right, and that's going on here as x approaches infinity, y approaches infinity, but as x approaches negative infinity, you would think negative infinity. No, the answer is it approaches 0. And we'll see that the minute we draw our sketch. Here I am approaching negative infinity in the x direction. And I'm approaching y equals 0 in the y direction. Okay, so that's just a rough sketch of y equals 7 times 3 to the x. Okay, moving on. 28, we got a function y equals 1/3 to the x plus 4. Y-intercept, again, x equals 0 at the y-intercept. So we have 1 plus 4, we got 5. Anything to the 0 power is 1. All right, so I'm going to mark that. Pretty important point on our graph, the y-intercept. Does this function increase or decrease? It's going to be a decreasing function. Remember, the key is that our base is less than 1. If the base is less than 1, it's going to decrease. Since this is a y-intercept, let's see. That's where it's going to intersect. But we also need to know where this asymptote is. And the question is, what are we going to get closer and closer and closer to without ever touching? And the answer is 4. You can keep plugging in smaller and smaller or larger and larger values to test this out for x. But what's going to happen is that 1/3, as we increase x, is going to get smaller and smaller and smaller. Think of raising it to the second power, third power, fourth power. It's going to be 1/9, 1/27th, 1/81st. All right. So then that's going to get added to 4. So we're going to stay just slightly above 4. So maybe I'll rethink my graph and I'll put my scale much higher and I'll go 1, 2, 3, 4, 5 as my y-intercept, and then I'll do a dashed line here for the asymptote. And again, this is a decreasing function, so I'm going to draw it like so. How does this function's graph compare to that of y equals 1/3 of the x? It's a translation or shift up 4 units. Horizontal asymptote, already labeled it and graphed it. It's y equals 4. Create a rough sketch. Done. Moving on, identify the domain and range. Okay, domain, we're going still from negative infinity to positive infinity, all real numbers. But the range is going to go from 4 to infinity. And behavior as x goes to positive infinity, y is going to 4. And as x goes to negative infinity, y is taking off like a rocket up to infinity. After graphing several exponential functions today, what makes an exponential function increase or decrease the base?